morning, wherever you are, and welcome to the presentation from infinityPV. Uh, I'm delighted to introduce Frederik Krebs. He's the CEO of infinityPV, who are based in Denmark. And today he will tell us about road-to-road printed solar and a couple of challenges and maybe how they solved these challenges. Frederik, with that, over to you.
Thank you, Christoph. Yes, the title has been mentioned, so I'm just going to jump straight in there and start briefly with a little about my background, and then you maybe will understand better the rest of the talk. I have been in the field of printed solar for a very long time. I started when the organic solar cell was a curiosity and only really mastered by people like Alan Heeger, Richard Friend, and their acolytes, so around 2000. I found already from the beginning that metal evaporation and glass substrates were rather contradictory to the vision of OPV, and started printing OPV already in 2003, aiming at printing all layers, of course, but at that time printing was difficult and evaporation was much easier. I had the first flexible printed devices, still ITO based, but partly printed, partly evaporated in 2004. Made up to 1.1 square meter panels. The solar had many demonstrators of that sort using ITO-based flexible substrates. I got rid of ITO with the first really ITO-free, fully printable process that I dubbed I1. It was the first ITO-free process, so hence ITO3 number one, or I1 sounds like I1. I didn't, but it still was a nice process, and that was in 2010, and that enabled massive scale panels to be made. So we of course exploited this fully very quickly. So made 100-meter long, fully printed panels giving 12 kilovolt at VOC, fill factors of 60%, huge panels with 1.3 kilowatt output. I also made a long list of demonstrators, too many maybe to count here, and this has always been a driver for me to actually take technology and demonstrate it in real life and also find its shortcomings. And really, that's, I think, how technology should mature onto the market. Lighting Africa, pocket lights, OEA demonstrators with laser pointers, grid-tied demonstrators, many of them, chargers, exhibitions, museum displays, etc. And this I did from 2006 to 2014 whenever I could. And then I started infinityPV along with a lot of other people in 2014 and made OPV commercially available already from the start in 2014 to anybody. So no paperwork, you just buy it and that's it. And then I also have a demonstrator that I will use in this talk, the Helion, and I'll use it as an example to show some of the you could say the innings of organic solar. So the company was founded in 2014, as I said. A lot of people in this company with a lot of experience. So we are a very knowledge-heavy company, almost crowdfunded in its making. 32 people initially, equal co-ownership. We had several patents and no external investors. And to this day, we still don't have any external investors. And what we do, we roll-to-roll print solar cells. And on this, along this way, we had to. Oops, sorry, something happened with my mouse there. We had to develop both materials, methods, machinery, and test systems and electronics, and this we also sell, of course. But that was really the path to a printed solar is a long and winding road, you could say. And I think it is really a disruptive technology, printed solar, and that's not only OPV. This is at my heart, but there are many other solar technologies that can be printed. And I think it comes from the lightweight. It's relatively robust still, has low impact. Generally, when you choose to print, then you are granted this low impact environmentally and machine-wise, etc. It's easily scalable when you use roll-to-roll manufacture, and it is flexible. If you look here to the right, I show a typical silicon panel, 4mm glass. It weighs 20 kilos, has relatively high thermal conductivity, and gives 250 watt peak. There's a small man there to show the scale. An OPV panel is a tenth of the weight. Maybe even the area is larger by a factor of 2, but it's a tenth of the weight at half the power. So